This is a video about my experience in converting a central heating system from diesel, and here you can see the diesel system with a blower up top and the diesel burner below, having taken the front off the unit. We want to convert that to reverse cycle air conditioning with an indoor unit hidden behind all this ducting, and an outdoor unit of course, just like any reverse cycle system. And one constraint we had is that we wanted to be able to fit the whole unit into the existing utility room beside the water heater. And you can see that the front wall and door have been taken off for ease of access. So that made a challenge for us to fit all the ducting in there, and we've managed to do that. When we take the diesel system off, you can see two ducts going through in the floor system. They're 220 millimeters diameter. This one leads to 5 vents in the house, 5 floor vents, and this one leads to 7, and that's been discovered by blowing air and seeing where it comes out. So we have ducts like that, 12 in total in the house, and they'll be used in the new system, plus one extra duct. You'll see how we did that. And we had a little bit of information left by the builders from 1977. When you look at the ducts inside, you can see that they're ceramic and really quite nice and smooth on the edges. And when we look around this corner, you can just see an outlet to the left there. That's a 150 millimeter diameter outlet, and all the vents have 150 millimeters going to them. On the left hand side, the 220 millimeter steps down to 150 quite quickly, and you can see an outlet to the right, which is just opposite the air intake grill that we'll put in. And this further continues up to the other end of the house with 4 vents up there. Now, some of the issues are that we were told that we can't do that, largely because the ducting would be too small. The diesel heat is very high and the volume required to heat the house is much lower. But we found that was not a problem. In the end, you can hardly hear the noise of the air coming out of the vents. And the choice of the AC unit is important. That's critical. I'll talk about that. We wanted to fit it into the existing utility room. And the last thing I've got here to notice is that with a system like this, you've got a lot of inertia under the ground with the ceramic ducts and also the concrete slab taking some time to heat up the system. That means that for some time, the air coming out of the vents is not hot. It takes probably an hour or two for that to heat up and eventually get up to a reasonable temperature. So this is not something you do for a quick heating or cooling of the house. This is something that you might leave on for the winter to work away in the background and keep your house warm. And with good insulation in the system that you'll see we put in, that is still very efficient. So next I'll talk about the choice of air conditioning unit, and I'll deal with this quickly so you can pause and look at the spreadsheet if you like. In yellow here is the unit that we adopted. It's 9 cooling and 10 heating kilowatts, and the 3 key reasons we went for it is its liters per second supply of air is very low, with a top of 400 liters per second. Secondly, its static pressure, which means how hard it can push, is quite high compared to others. And thirdly, its dimension is such that it would just fit in. We did get one quotation which listed this Dakin. It was higher airflow, which was not so good, and also lower static air pressure, not so good, and very much wider, also not so good. So we weren't so keen on that. And also they wanted to have about twice the floor area, so we were going to have to knock down walls. So our second choice was this Actron Air. It still has higher liters per second airflow, which at that stage we thought was a big issue, and now I'm not too sure if it really is. We did not have a static air pressure value for that in the literature, and when I phoned them, this is what they said up here, so it sounded as though it might be quite good. And lastly, effectively 850 wide is what was going to be good for a fit. So this would have been the best fit, but we went for the yellow one, the Mitsubishi. Most of the rest of this video is made up from clips that I've made during the job. I hope they make sense. First of all, here's the return air grill. So that's a supporting plate of steel to support the bricks above the hole. Hole's been started with a drill, and then I'll be using this tool which should get through brick and concrete. But indeed the big diamond cutter is the way to go. Very quick and easy for most of it, and the other tool for little bits. So a great deal of dust later, and that block of brick is actually completely isolated from the rest of the wall. It just dropped a little bit. And it's very, very hard stuff, good bit of concrete in the mortar. And here it is on the other side, just rotating it out. And that's 75% greater area than the intake on the unit, so I think it's going to be quite fine. And that's it coming out this way. Not the ideal placement for a vent, although I might vent that air along the wall here and away somewhere else, but this is the return air grill. and the hole in the wall going through to the other side. And if we go around the corner, we'll see what that looks like. There we go, 7 rows by about 2 bricks wide with a steel support above to help the brick work. And this is the table which the indoor unit will sit on, and it is fully adjustable at each corner, actually holding onto the water tank, which we can change if we need to in the future, and using tubing for leveling that table between 0 and 5 mils down on the right is what's required. And what you see here is to hold the supply side ducting, where I've got a couple of blocks coming out and they can slide along that, which means I can introduce the supply side ducting onto the indoor unit when it's up there and slide it along and engage it, and you'll see that. But the next job is to build the return air plenum out of cool room panel, foam panels, and that you'll see soon on the back of that wall. Next I'll talk about the return air plenum built out of foam board. You can see it here, and the key feature here is to have it very close to the wall to maximize the use of space. And even with that 200 millimeters away from the wall that the indoor unit sits, there's virtually no constraint on the unit, and that's seen in the pressure readings that I'll show you later in the video. This is the return air plenum, nearly complete. So the foam board is in for the sides, 200 mil deep. The top piece has been glued in at the back, and this side piece just at that corner, a little touch as it goes past that power junction, then a touch at the bottom. The bottom isn't glued at all, just bolted in, and this side is screwed into the wood on the wall. And the front piece is going to be put on with these 4 studs, 1, 2, 3 and 4, and it's quite heavy, so it's actually going to sit on these 2 pieces of tile, try and keep the bottom of it dry. And that's the front piece here in MDF, which will bolt on. And at the top, just above that front piece, there'll be a bit of foam board which will complete the ceiling with the inside unit which goes in up here. Next is the supply air plenum, which is essentially the start of the supply ducting, and the indoor unit is going to push air into this aperture here and it'll come out here, and you can see we found an alternative use for this piece of equipment. Here we go. So the next job is to convert 2 pieces of galvanized steel at 25 bucks each from this into, Ken from over the road knew exactly what I was making. Here it is, complete with a shadow. Just about perfect for the job. So this is the start of the fabrication work with a chimney pipe being used to join 2 sides. And this is a nice tool for making easy work of it with the pop rivets. So we'll pop that in there and then just give it a little push and pulls it in nicely. So this is the supply side air ducting coming along, and the hot air goes in past that black painted angle iron, painted black just in case there's condensation, goes through there and down there. And I've got another exit to put in, which will go over here somewhere for the extra bit of ducting that we're doing. This is the supply side ducting, just about ready to go. And I've added an inspection cover here. It's amazing what you can find at the dump. There it is down there. And I can take that cap off, put an air duster gun and clean the indoor unit's coils with the fan on. And that's just once every year or so. And this is a little spigot to put on a tube for the air pressure meter. And I've added this ductwork for the 200 mil ducting to go into the lounge at the bottom of the stairs. That's something I've added myself. But for all the other vents, they're supplied by this 400 millimeter diameter duct here. This is engine compartment heat shield and soundproofing that sticks on, and I've got that placed every square inch of it that I had left over, put on the places that it's useful to have it, because gravity will hold on polyester insulation in many places. Also a gap on this side that you're looking at will be held in against the wall. by polyester. But in addition, I'm going to wrap the whole thing as much as possible in this glass fibre, unfortunately, and foil insulation R1.8. Although, as I said before, quite a lot of the surfaces can be insulated with polyester bats put on the surface, and gravity or grabbing between the wall and the unit will hold them in there. I'm applying a sealing gasket to the intake side. It's nice D section, quite deep, and it compresses down to about 5 mils, just like that. That's the indoor unit sitting on the table, and if we look at the back, we'll see that it's ready to be pushed in with its nice D section gasket into the intake plenum. And that's the gasket, quite well squashed all around, and that's been held in by a piece of wood which is set up like that to pull in. So you can see the indoor unit is sealed on the sides and top, but not on the bottom. It's actually going to be sealed on the bottom of the unit rather than the front of it, with that gasketing. And there's the last piece of polystyrene ready to fit in there. So that's the last foam block installed, and the threaded rods are bolted into the wall, which has got these inserted into them. And the inner nut here is done up not too tight because it's just going against the foam, whereas the outer nut is done up quite firmly to help hold the table in against the pressure of the rubber gasket that's holding the indoor unit into the ducting. This is the air intake sensor ready to go in. It's just a hole, and the metal spindle in the middle is just a guide. And now that the machine's been gassed up, that's all ready to go into a hole at the back there. And now I was ready to fit the supply air plenum, and it bolts onto the indoor unit with bolts here, here, and very difficult to see right on the other side. So an endoscope helps to see that and to articulate tools to get in there and do it. Here we go. That's the unit in place. It's held on up at the indoor unit by these 4 small 6mm nuts. And on the other side, it was quite good fun getting it in there. And you can see I've got little spacers in here so that I get a consistent gap in my gasket all the way around, in fact. And this whole unit is actually sitting in here very solid. Can't really move it at all, but I do have a nut there which I want to put through the MDF for the return side. And I just use my lathe to put a hole through this bolt, and so that means I get a good guide for drilling through to get to the right place on the other side through the MDF. So after a big rainstorm, there was a little bit of water, just dampness got in, so I've siliconed a rubber dam in there where the pipes come in through the brickwork. And I'll detail this a little bit better so that there's no water coming in the first place. Next is the issue of how to get the supply air coming from this 400mm duct through into the twin 220mm ducts in the floor. And I chose to maintain this volume as a plenum and just bring a duct down and fill that plenum to push into these 2 ducts. Here we go. This is the lower plenum for the supply side under construction. Still got to make it aerodynamic for those intakes. And in the old diesel system, this was just bare concrete, so helping to warm the planet it was. If you've ever opened out the ports in a 2-stroke engine, you'll have enjoyed this job. So it's all well insulated and made a bit more aerodynamic. And it'll be painted quite well so that we don't have polystyrene in the system for breathing fumes. So I've put thread inserts into the concrete and put threaded rod in there and spacing that out about 4mm. That's the D section gasket or foam roll, which is 3M. And on top of that will be bolted this board with a spigot leading up to the supply ducting. And here's the gasket squeezed up. I've got approximately 5 mils in the concrete being higher than the polystyrene, plus I spaced the board up about 4mm off the concrete, which helps to keep water off the board if the water gets in there, and I think that's about the right amount of squash on the gasket. The next step is to connect the 400mm flexible ducting, and I stood it up in the shed this way so that I could cut it easily, and here it is installed. And you'll see progressively I put more and more insulation in there, no point in having heat getting lost. But first a little test. So with the extra duct blocked off, I've gone around everywhere and no sign of any leaks, which is great. And yet more insulation and storing the 400mm ducting that wasn't used in there. Find the bit of wall and put it back on, and everything closes up quite neatly. And now you'll see this green ducting here. It's called Eco Duct, and it's the subject of the extra vent that we have coming out, and it comes across this gap, nicely finished off in the end, and into a vent in the house. So let's go and have a look at that. This is the extra vent that I put in. It comes out of the system, actually goes through with the green Eco Duct, which you'll see in that box underneath this floor. And so you'll see some underfloor video, and that'll be where it goes, under that bit of floor. And the Eco Duct, the green stuff, which is painted black here, comes out here and supplies the 13th vent for the house. So I've chosen this Eco Ducting for the extra vent, and it's 300mm by 70 rectangular section, and that's so that it can fit nicely across this gap through a hole in the house wall there and underneath into the subfloor space. And I found that heating didn't bend it so nicely. I needed a small bend, so a bit of cut and pop riveting did that. So we start here with a junction piece. We can join that with 200mm flexible ducting, which I use underneath the floor to join from here to here, in fact. And so that's us going across the space under the subfloor and in underneath the stairs. And of course that all gets nicely insulated afterwards. Then there's the issue of the hole in the stairs for the outlet. And that's Sandy cutting a hole in the middle part of the stair. And I finished off below the stairs with a nice easy sliding vent cover, which I won't need to bend down to open. It just opens and closes quite nicely with a slide. And then adjust it to however large the opening has to be. This is the pressure meter I have attached to the system at all times, and the inlet side has got virtually no pascals of suction. The outlet side is most of that, 86 or so. That is with the fan on full. 4 of the vents are fully blocked off with foam rubber, and the vent opposite the inlet grill is largely closed, and the vent at the bottom of the stairs, the extra vent, is fully closed. And so we're very far away from being near the limit of the system. It doesn't seem to be any problem there at all, especially considering that most of the time we're going to be on fan level 2. That's what our experience is, and it's much quieter and slower, and the pascals go down from about high 80s down to about 25 or 30. So plenty of room there and very little stress on the system. And the good news is there's very little noise coming out of the vents. So the outlet vents are essentially silent, even at full fan, so there's no issue there. The biggest noise comes from the intake grill. Here it is, and that can be heard, but if we put the fan speed down to 2, which is where we find it mostly sits, it takes a really while to reduce, then that noise goes away, such that if I'm sitting in my chair over here, I don't hear it at all, just fine. So still with pressure and noise. With the old diesel system, the vent noise was not too bad and quite acceptable, and when I looked at the blower unit and did some calculations, I reckoned that we had somewhere above 550 litres per second coming from that. Now if I'd had an air pressure meter, I would have taken some recordings and probably been able to go for a larger AC unit, but as it is, we're quite happy with what we've got. The new system has a maximum of 400 litres per second, and on fan speed 2, 250 litres per second, and the vents are virtually silent at that point. The other good news is that with the static air pressure limit for our unit at 200, we never got near that, never above 90 pascals, even with a lot of the vents closed. The return air noise is acceptable, especially at fan speed 2. And the noise was not so much coming out of the grill, and thank you to a nice granddaughter for making a sign not to lean on the polystyrene. So the noise was not coming from the grill here, but further up at the actual unit. So some wind noise, probably a bit of mechanical noise, and so little constraint on the system at this side that I could probably put some baffles in here using the same foam boarding perhaps to make the air take a convoluted route and give more silence at the air return grill. Now just a quick look at insulation and heating. I've got a FLIR camera that attaches to an old iPhone, and that works out quite nicely. Here is the system before all the insulation is on. It looks better than it really is because reflection off the silver paper gives a false reading, but generally the temperatures are looking not too bad. Later on, when everything is nicely insulated, it's really just the pipes connecting to the indoor unit that are showing a lot of heat, even though they are quite well insulated. Here is the join between the indoor unit and the ducting before any insulation is put in there, so that's just raw steel. And here's the turnbuckle that I used to support that end of the intake ducting. So that's all insulated in this picture and very little heat loss there. And going across the gap to the house, there's very little heat there. You can see that's only 11 degrees, although this is not really calibrated well perhaps. Underneath the house, this pretty picture shows that there's a bit of heat loss just where the ducting comes through the hole in the floor because there's not much room to get insulation in there. But that's not a loss because the heat under here comes upwards and into the house. Here is the air intake grill. This is where we have a split of the two main branches going up this way to the top of the house and down this way to the rest of the vents. Here's the vent opposite the intake grill with some washing drying. It's very handy for that. And if we go up to the top of the corridor here and look downwards, you can see that that branch is heating the slab quite nicely. Here's the vent underneath the stairs, and the stairs themselves giving a little bit of heat into the house. And generally you can follow the route of the ducts just by looking at the FLIR camera. Quite useful for that. And it's nice to think of that heat convecting upwards and coming into the house, but unfortunately it doesn't work that way. The convection requires movement in a liquid or a gas, and the solid stays solid underneath the ground here, so the heating goes downwards as much as upwards. However, the ducts are well within the footprint of the house, and that means that once the system comes to equilibrium, we'll be capturing the benefit of the heat that comes out of the unit and into the house. So I'll finish off with an idea of what it cost for me. The air conditioning unit was just over $4,000 from Mitsubishi, plus $500 freight. Various bits of ducting and fittings, that came to $1,000 or so. And the electrical and air conditioning connections were made very nicely by Sam and his team. Thank you, Sam. That was $2,200. So a total of somewhere under $8,000 plus my labor. And thank you for watching this video. I've just been motivated to share my experience in case I can help anyone else who's going down the same road as me. And I'd like to thank my wife and son in particular. I forget their names at the moment, but there you go. And various friends. And these people all helped with painting and pushing and varnishing and these sorts of things. So there you go. Thank you for listening.